Welcome back. All right, we're on to page 2. So in this one, we're going to write the equation for the following functions, and then we're going to answer the question to the right. So you can actually do this first and then write the function. That is up to you. But I'll do the function first. So this is a square root shape, so you will have to keep in mind that this is the square root formula shape. And again, a great thing to have written down for when you take your chapter 3 test. And this is the cubed root shape, which just has a cube root as its index number. Okay? So what we'll have to do is establish hk and xy, and then we can do the math to figure out what a is. So hk in a square root function is always the endpoint. So this -3, 0 will substitute in for h and k, and then I just need some other points. So I could use this point, I could use this point. It really doesn't matter. I'm going to use this point, and which is 1, -2, and that will become the x and y that I put in there. So I'm just going to replace these letters with these numbers, and then I'll do the math to solve for a. So y is going to be -2. I'll figure out a. In my check mark, I'll take 1, and I will subtract h. And then outside of the check mark, I'll add k. And now I'm just going to do the math to solve for a. So a will just basically disappear, or not a, 0. And then inside the check mark, 1 take away -3 is like you adding 3, and that will become the square root of 4. And when I take the square root of 4, all of this becomes 2. And now to solve for a, I would just divide and get -1. And then I can write my function. So the function wants to look like it did when we graphed. So you can use y or f of x, but those x and y stay as x and y. So here's my function. All right, so it goes y equals, or you could do f of x, it doesn't matter. A, which is -1, that would be a flip. It is a square root with x minus h, and then k at the end. So you probably wouldn't see it written like that. You would actually see it as probably just a negative, and that would become x plus 3, and then you wouldn't even see the 0. Oh, that's kind of a glare, but it doesn't matter. If it's multiple choice, it would matter because you would see this and not this. What's my domain? So let's get these points marked. So I already marked this point. This arrow means infinity, -infinity. So domain, remember, is your x, the smallest x and the biggest x. And in domain and range, when you have a number, you use a bracket. In range, I want the smallest y and I want the biggest y. And most of you might be tempted, not most of you, but some of you might be tempted to go 0 and -3 because that's how we did the x's. I'm sorry, I said 0, -3. I meant -infinity. But -infinity is the smaller value and 0 is the bigger value. So I'll write it like this, bracket on the right, parentheses on the left. And behavior, boy, I haven't written this for a while. This is one setup. So as x is getting bigger, what are the y's doing? Well, they're getting smaller. And then I would write the other one. And what I notice here is x, I never had a -infinity. So actually, as it turns out, this does not exist because x never went to -infinity. X just went to -3. So I can't answer this side, but I don't not fill it out. I just say it does not exist. All right, the second one. So here, finding h and k in the cube root is definitely a little tougher. So what happens when you graph, when I was talking about in the graphing section here, if you don't have graphing paper, you just focus on these 3 points, which were the 1s and 0 points. So if you notice, you got these 2 key points, and then the 0, 0 is going to be the one right in the middle. And that 0, 0, when it moved, was the HK. So where you want to look for are those 3 points right in a row, and you want to go for the one that's right in the middle. And it will be a nice, clear, easy point, no decimals. So this is 1, 2, and that will be h and k. And then I just need some other points. So if you want to stick with smaller numbers, you could make this, which is 2, 4, be the x and y. Or you could use this point, or this point, or this point, or this point. But I'll just use those. So n for y will go 4. We're going to figure out a. Here comes my cube root. N for x is 2. N for h is 1. So 2 minus 1 plus k, so plus 2. So again, I just want to focus on this cube root. 2 take away is 1, and then the cube root of 1 is 1. And you can put the 1 with the a, but really you don't need it. I'll drop it in the next step. So now to get a alone, I'll just subtract 2, and we get our a value. And now I can write my function. Y equals a. I'll set my cube root up. X minus h, which was 1, plus k, which is 2. A great way to check your answers is to go to your y equals button, plug in your equations, and look at the table, and you should see these numbers in your table. All right, let's talk about this. So let's start with the end behavior. I'll just work backwards. So okay, let's mark our key points. So this arrow is left and down, so they're both negative infinities. This arrow is right and up, and I want to go where it hits the x-axis, so 0, 0. And usually we get like a major turning point. A major turning point would change it from up to down or down to up, but this is going up all the way, so I won't mark any key turning points. So my end behavior, as x is getting bigger, I'll put in for f of x at infinity. And when x is getting negative infinity, I'll put in for f of x negative infinity. So there's positive and there's negative. So as I go left to right, you know, this part is negative until it switches to here, and then it's positive. So for the negative, I'll fill out the negative first. It's, you know, I'm looking at where the y's are negative, but I'll use the x's to explain the answer. So it's negative from negative infinity to 0. And then at 0, it switches from 0 to infinity as positive. And this is where we use parentheses. All right, last section, and then we'll start our next video. So again, this is a more recent section for us. We're going to simplify the radicals. We want to classify them. I think we're good with our square roots, but I would maybe make a little note over here, like some cube root numbers, like the cube root of 1 is 1. Another nice cube root is 8. The next one would be 27. The one after that would be 64. And after that, I think 125 is as big as we get. And if these were negative numbers in here, then their answers would just be negative. So maybe make this note, because it would definitely help if you fill this out and you have your chapter test. So I'm going to go, we got 3 or 4 functions, and I'm going to go to k's function and just put 81 in there. And the square root of 81 is 9. So I'm just going to put my answer right there. Pretty simple. Now I'm going to go to f's function and put 25 in. So this is what we were talking about. You know, I don't know 25 to the 3/2 power, but if I rewrite it, that 2 is the little index number, and the 3 is the exponent. And then I can take the square root of 25, which is 5, and then I can take 5 cubed, which is just 5 times 5 times 5, and I get 125 when I'm done. And I'll just put that 125 right there. All right, let's go to g's function. Let's put a 1 in. So I'll get 8, because I multiply first, and then 8 plus 4 is 12. So one thing that I did not read out loud were the directions. Evaluate the following and simplify all the radicals. Well, so far we have. But 12 isn't perfect. However, there are factors that are, and then it can become this. Now there's more to the directions. Classify as rational, irrational, or imaginary. I'll do that when I'm done with this section. D is go back to k and put in negative 25, and normally we would have said, nope, that doesn't work, but now we can. When you take the square root of a negative number, you take the square root of the number, which is 5, and then you put an I at the end, which stands for an imaginary number. Let's go to h's function. I'm going to put negative 4 into here. And I talked about in class on Thursday, that's today, that you should always put that in parentheses in case you're letting your calculator help you. But negative 4 squared is negative 4 times negative 4, which is 16. And once I add that to 11, I get 27, and I'm just going to put the 27 here. I'll put the 5i up here too. And finally, another composition function. So based on this, I'm going to go to h's function and put a 5 in. So I'm going to put a 5 in here. So 5 squared plus 11, let's just keep that in parentheses. So that's 25 plus 11, which becomes 36. So all of this in parentheses is worth 36. Sorry, I don't think you could see that. And then I'm going to bring the k down. And now this says go to k's function and put 36 in. And when I'm done, I get a really nice number. I get 6. So last part of this section is, are the numbers rational, irrational, or imaginary? Well, anytime you get an I as an answer, that's imaginary. So what's the difference between rational and irrational? Rational numbers are numbers that are really easy to remember. If I covered this up and I said, okay, you got 2 seconds to memorize it, you could remember it. They're numbers that if there are decimals, they're short decimals or repeating decimals. So this is a rational number. Rational people are easy to deal with. 125, that's an easy number to deal with. Down below, 27, easy number to deal with. But on this one, 2 squared root of 3, granted I could remember it, but if I did type it into my calculator and went for the decimal version, and I showed it to you and I said, okay, look at it, can you tell me what it was? You probably wouldn't be able to remember it. So that is what we call an irrational number. And when we were done, 6 was a nice number, so that is rational. So that's video 2, and then we will finish up with our third video, which will cover the last page and a little bit more of this function operation.